In high and large spaces such as industrial factory buildings, normally there are three types of terminal air conditioning units commonly applied for cooling solutions: jet flow type air conditioning unit and modular air conditioning unit with ducting. AirTS high and large space air conditioning unit. The following is a comprehensive introduction to AirTS high and large space air conditioning unit from several aspects: device structure, working principle, operation mode, precise temperature control, air-water linkage control, wireless communication, data collection and control, and remote operation and maintenance, and also includes the main terminal integrated collection control system. While presenting these technical points, we also make comparisons with jet flow type air conditioning units and modular air conditioning units in order to provide a more comprehensive understanding and knowledge of AirTS high and large space air conditioning unit. The heat exchanger on top of the device utilizes our company's patented mouth-shaped coil design. As hot and humid air passes through the heat exchanger, condensed water adheres to the vertically positioned aluminum foil fins. By accurately calculating the wind pass area, even at maximum wind speed, airflow passing through the fins remains below 2.5 meters per second, preventing it from overcoming gravity and carrying down condensed water. This enables automatic drainage of condensed water into a tray under the heat exchanger, effectively resolving any leakage issues. With its four-sided configuration, our heat exchanger offers a larger overall area and wind area compared to flat-plate structure heat exchanger used in jet flow type air conditioning units. Thus, it has minimal air resistance while maximizing both air volume and cooling capacity within limited space. Axial fans are under the heat exchanger. We have been working with the world's top axial fan manufacturers, Zeelabeg and EBM from Germany, for nearly 15 years. Compared with the centrifugal fans used in jet flow type air conditioning units and modular air conditioners, axial fans have large fan diameter and low RPM, which makes them have large air volume, low power consumption, and low noise. The fan is built in the device, and rubber and plastic sponge are pasted inside the device shell. Although it is an industrial device, the noise is extremely low, suitable for cinemas, restaurants, shopping malls, conference rooms, and other spaces. The heat exchanger adopts a four-sided return air design and has a smaller wind resistance. At the same time, the fan is placed at the bottom and works in a negative pressure suction mode, which can achieve a uniform airflow velocity distribution at all positions of the heat exchanger and make full use of the entire heat exchanger area. The overall structural design of the device has been highly recognized by the expert group, and a large cooling capacity and air volume have been achieved under the same power consumption. By comparing the three types of device, it can be clearly seen that under the conditions of obtaining the same cooling capacity and air volume, the electric energy consumed by AirTS high and large space air conditioning unit is much lower than that of the jet flow type air conditioning units and the modular air conditioners. Especially for the modular air conditioners, the air volume and cooling capacity are the values measured when the air duct is not connected. In actual application, the airflow delivered at the final outlet is even less due to the long-distance attenuation of the air duct and the resistance generated at the turning point. Below is a comparison of three types of terminal air conditioner schemes for a mechanical processing plant with a height of 18 meters and an area of nearly 10,000 square meters. Using AirTS high and large space air conditioning unit requires only 19 units with air volume of 10,100 cubic meters per hour for each unit, while using jet flow type air conditioning units to achieve uniform temperature effects requires 50 units with air volume of 5,000 cubic meters per hour for each unit. Each AirTS high and large space air conditioning unit has larger airflow and cooling/heating capacity, resulting in fewer units required for the same project. This simplifies the system and significantly reduces construction work. Besides, as the device is suspended under beams without requiring additional secondary beams, installation does not damage the structural integrity due to the use of finished steel hangers. The device also does not occupy any floor space, making both the space and air conditioner neat and clean. The equipment is suspended in the exact center of a span, with a passageway under, facilitating maintenance and servicing operations using an elevating platform. It can be observed that for AirTS high and large space air conditioning unit with the same cooling capacity, the power consumption is half of that of jet flow type air conditioning units and 1/4 of modular air conditioners. In a 10,000 square meter factory, using AirTS high and large space air conditioning unit results in daily energy savings of 326 kilowatt hours compared to jet flow type air conditioning units and energy savings of 878 kilowatt hours compared to modular air conditioners. Over the course of a year, the power consumption for AirTS high and large space air conditioning unit is significantly lower than that of modular air conditioners, with values being 32,832 kilowatt hours and 138,240 kilowatt hours respectively. The above comparison is only the power consumption of the fan during the operation of the three types of device, while the energy consumption of air conditioning device is mainly the consumption of cold and heat, which is dozens of times the power consumption of the fan. Whether the lowest cold and heat consumption can be achieved while accurately meeting the target temperature is the key, and it is a technical point that air conditioning device manufacturers pay more attention to. The following introduces the overall operation mode of the unit and precise temperature control. AirTS high and large space air conditioning units are hoisted on the roof, and the built-in heat exchanger is used to quickly cool the air. Then, use efficient air distribution device swirl diffuser to quickly deliver the cold air from top to the ground, evenly distributing throughout the space. In high and large buildings, when the device is initially started, the temperature are higher in the entire area and the device works at the maximum cooling output state. As cold air continuously delivered to the ground, the working area temperature continues to decrease. As the temperature in the ground work area continues to decrease, the precise temperature control function of AirTS high and large space air conditioning unit monitoring system starts working. The entire system consists of three parts: the main control computer and software system, air conditioning device, and wireless thermometer. The wireless thermometer can be placed anywhere with a 220V power supply. The main control computer automatically inspects the wireless thermometer data and device operation data through wireless communication. The temperature data collected by the wireless thermometer is compared with the target temperature value in the corresponding time period set in the system according to time. If the data collected by the thermometer is lower than the target temperature set in the system and has lasted for a certain period of time, the system will send real-time commands to the device. Based on the current data collection, decrease the fan's frequency. By reducing the fan frequency, airflow will be reduced and output cooling capacity will decrease accordingly. Once the frequency reaches its minimum set value, shut down the device. During this time, cold air above 2 meters will automatically descend to compensate for cooling consumption in lower spaces. This process will continue for a certain period to effectively utilize excess cold air. When inspection detects that thermometer temperature is higher than target temperature set in system, device will automatically start up and run at minimum frequency. After running at minimum frequency for a certain period of time, if thermometer detects that temperature still exceeds target temperature set in system, then real-time commands are sent to increase fan speed based on current device operating frequency obtained from data collection, increase device airflow, and enhance output cooling capacity. The goal of precise temperature control is to not increase the cooling output while meeting the ambient temperature requirements, and try to keep the cooling capacity in the bottom space without overflowing, so as to achieve the most ideal effect of stratified cooling. After the device is running for a period of time, the temperature of the ground working area reaches the target temperature. Since the insulation of the factory with cooling demand is good, the total cooling output of the device and the cooling loss and consumption in the factory can be balanced at this time. Very low cooling output can keep the temperature of the working area. The entire temperature control process is a state of reaching the target temperature and maintaining balance. When approaching the equilibrium state, the operating frequency of the device fan is very low, with low air volume, low noise, comfortable feeling, and lowest energy consumption. Based on our years of data accumulation of the main control system and the experience of remote operation and maintenance, the device will work at the maximum wind speed and maximum cooling capacity when it is initially started, but it will soon enter energy-saving balance state, and the power consumption of the fan and the cooling capacity from the water system are reduced to a minimum. The jet flow type air conditioning units need to operate at maximum airflow in order to deliver cold air to the far end from the air outlet. It cannot be adjusted with variable frequency control. The device starts operating at maximum airflow and cooling capacity when it is turned on until it is shut down at the end of work hours. Prolonged operation will result in excessive cooling, causing a decrease in temperature and ineffective cooling of spaces beyond 2 meters. Cooling is similar to filling a reservoir with water. Without controlling the water flow, it will overflow and fill up the entire reservoir. Besides, during the process of delivering air, there are blind angles for airflow at the bottom and sides of the device. Close to the jet flow type air conditioning unit results in strong wind sensation, low temperature, and loud noise, while distant areas experience lower cold airflow and higher temperatures. The overall distribution of environmental temperature within space becomes uneven. If adopts the jet flow type air conditioning unit with high air volume, there will be fewer devices but higher wind pressure. People close to the devices may feel uncomfortable, and there will be blind angles due to large spacing between devices. If small air volume device is used, the overall temperature field balance can be improved, but there will be more devices and crossbeams need to be installed between adjacent columns, resulting in high construction costs. Placing the units at a high position will result in larger blind angles below, while placing them at a low position will have limitations on installation locations and require avoiding obstruction from production device to ensure unobstructed airflow. The modular air conditioner delivers processed air to the entire building through air channels or ducts, and is equipped with air outlets to deliver hot and cold air into the space. The system needs to operate at the maximum output of the fan to ensure the air output, and the cooling output cannot be adjusted. Running at full load for a long time will cause the cooling capacity to overflow and cool the entire space, making it impossible to achieve stratified cooling. Air ducts materials, insulation, and construction costs are high, especially in high-rise factories that involve high-altitude operations. The initial investment of the project is large, and the wind pressure is attenuated greatly after being transported through long-distance pipelines and turning. Heating needs to overcome the heat drift effect to deliver air to the ground. It needs to provide extremely large wind pressure and air volume, and the power consumption is high. The electric energy consumption of fan operation is 4 times that of AirTS high and large space air conditioning unit. Dust accumulation in the air duct breeds bacteria, making it difficult to clean, and the quality of the air output decreases, which is not good for people's health and the environment. Modular air conditioners require large initial investment and high subsequent operating costs. It has advantages in environment with purification requirements, but it is difficult to achieve air purification requirements by terminal air conditioners. Fresh air function can be introduced, and AirTS high and large space air conditioning units have matching fresh air unit series products, and there are a large number of practical application cases. AirTS high and large space air conditioning unit can achieve stratified cooling and precise temperature control, which are closely related to the unique air distribution and swirl diffuser of the device. How to deliver cold air down to the bottom space and distribute it evenly over a large area. In addition to model selection, the swirl diffuser is the core technology of the device and is a careful design of fluid mechanics. When the air flows through the silencer, sponge, and tray components, the wind passing area is sharply reduced and the wind speed is greatly increased. This is the first pressure increase. The air flows through the trapezoidal closure, and the entire lower part of the device has a trapezoidal closure structure. This is the second pressure increase. After two pressure increases, the outlet wind speed can reach to 16 meters per second, and the air supply height of the device in pure cooling conditions can reach 25 meters. The 12 guide fan blades at the air outlet can rotate in the same direction driven by the actuator, which can realize stepless adjustment from vertical air supply to horizontal air supply. The swirl diffuser has three combined states of jet flow: swirling flow, diffuse flow, and intermediate transitional flow. In the normal cooling mode, adopt the vertical air supply method. The wind is delivered downward to the ground, and the cold air spreads along the ground to all sides under continuous positive pressure air supply. The horizontal air supply method is generally used in pharmaceutical warehouses, which require a cooling environment from top to bottom, or used in sports venues, where cold air is distributed horizontally and then sinks slowly. The air outlet of AirTS high and large space air conditioning unit is distributed in a circle. To achieve air supply from all directions, the jet flow type unit needs to use 4 devices and has blind angles. The air supply method of AirTS high and large space air conditioning unit is very smart. The air distribution range of a single device can reach 1,200 square meters, and the air supply height of pure cooling can reach to 25 meters. However, the height of most factory buildings does not exceed 16 meters. Due to the maximum cooling capacity is generally limited to a coverage area of less than 600 square meters, which leaves enough space for variable frequency air volume adjustment. A single device has a large circular coverage area, and the air volume and air supply angle can be steplessly adjusted to achieve a wind-free feeling on the ground and a more balanced temperature, meeting the needs for comfortable cooling. The installation method of high and large space air conditioning unit can be handled flexibly in practical application, and the side blowing method can also be used. The downward air supply device can be installed under the running track or on the column similar to the jet flow unit. The air outlet direction is all round with the device as the center. It is much better than the one-way air supply of the jet flow unit, and there are already many practical application cases. Each AirTS high and large space air conditioning unit has an independent control box, and the control box contains a main control board. The control and communication cables of the return air temperature sensor, outlet air temperature sensor, fan, frequency converter, wind direction actuator, and other components are connected to the corresponding terminals on the main control board. All functions of the device have been tested before leaving the factory. When the device arrives at the site, it only needs to be connected to a 3-phase power supply to be used normally. There is no other wiring and debugging workload on site. The main control board receives corresponding commands from the main control device through the wireless communication module, performs corresponding actions, and reports the results to the main control device. Based on this mode, the power on and off status, wind speed, air outlet angle, and other status of each device can be set independently and arbitrarily, truly achieving single machine, single control. There is a frequency converter in the control box, and the cooling capacity and air volume output of each device can be adjusted steplessly by inverter. If a proportional control valve is installed on the pipeline and the control line is connected to the reserve port on the device mainboard, the water supply flow of the device can be continuously adjusted to solve the problem that the height of the special factory building is very high and the wind speed cannot be adjusted too low. Principle of wind and water linkage control. The wind speed and intensity adjustment range can be set in the system. The system first controls the wind speed and intensity. If a satisfactory value is not reached within the setting range, the device's water flow rate will be steplessly regulated. If you prefer to use water flow to adjust, you can set the temperature control maximum wind speed and minimum wind speed to very close values, which is equivalent to the fan running at a fixed frequency, mainly using water flow for temperature control. The remote monitoring system currently supports the Windows system for computers and the Android system for mobile phones. It can remotely conduct data collection, parameter setting, operation monitoring, and device control of on-site terminal device individually or as a whole in real time. Monitoring personnel at the company headquarters can help users conduct energy-saving analysis based on monitoring data and promptly remind users when abnormal problems are discovered or go to the site for maintenance, providing users with proactive and timely services.